All right, you guys, sorry about that. It got messed up somehow. So I'm going to go ahead and go back here to 512. So I'm thinking of numbers that go into 512 that evenly go in there, but also something that is a perfect square. So I can run through a bunch of numbers. The lower the number in a number this big, the more difficult or more steps I'm going to have to take. I'm going to go in, I'm going to say 16. 16 does go into 512. I can run through a whole bunch of numbers, but I do know 16 is a perfect square and it goes in evenly. It's not the highest number, but I'm going to work with that. So I'll show you how to do this a little bit easier for those of you guys that don't want to sit and do this a million times. So 16 is a perfect square. It's 4. So I'm just going to take that and I'm going to reduce that down to 4. Now, 32 is not a prime number. It's not a perfect square, but I have a nice number that goes into it. And so if you think about 32 and what goes into 32, you think about perfect squares. Well, 16 also goes into 32 as well. So 16 is another perfect square again. And this is times 2. So 16 is a perfect, which we just did, and that is going to give me 4. So what I have here now is this is a prime number. It's not a perfect square. I can't do anything else with it. What I'm left with is 4, 4, and a radical 2. So what my final result is going to be 4 times radical 2. And what I'm going to do is just multiply the 4 times 4 because I can do that. And I'm going to get 16. And then I can't do anything with that radical 2 because I can't multiply that because this is a radical, these are not, so that's not going to work. So this is my finalized option for this answer. Now let's take a look at the one right below it. So again, you can do a few different things with this. I'm just going to multiply these two because they're radicals. I can do that. Again, they're going to stay radicals, but I'm just going to multiply 12 times 6 and I get 72. So what I'm going to have here is 3 on the outside, radical symbol, and 72. And then I'm going to think about numbers that are perfect squares that go into 72. I know right off the top of my head is 9 goes into 72. So I can certainly use 9 if I'd like. If I want to go to something a little bit higher, I can try something a little bit higher. And hopefully you realize that 36 also goes into 72 twice. So I'm going to use that because that's my highest option here. Now, if you use 9, you can do that, but it's just going to be a little bit more steps like this one above was. So 36 is a perfect square that goes into 72, and it goes in twice. 2 is being a prime number. Can't do anything with that. But 36 square rooted is going to be 6. So what I have is a 3, I have a 6, and I have a square root 2. So my answer is going to be 3 times 6. It's not actually my answer, but almost my answer. So I'm going to have what's left. So I have this 3, I have this 6, and then I have the square root 2. So I multiply the two numbers, 3 times 6, which is 18. And then I can't do anything with that root 2 because I'm going to multiply that times root 2. And that's as far as I'm going to be able to go with this particular problem. And that is all I can do. And if you want more questions like these, the two that you're going to see down here on the bottom, I'll do one separate video on how to rationalize the denominators. But you can find the rest of these videos and more like these at YouTube, Instagram, and TikTok at E1Algebra. All of these types of problems are going to be located in my Roots and Exponents playlist. And don't forget to like, share, and follow it for more. Save it for later, and I'll see you soon.